In this video, I'm going to have a look at gradients and give you a simple method for calculating them that you can use every time, and you won't really have to think about it if you remember this very simple method. Firstly, what is a gradient? Well, another word for a gradient is a slope. You can use the two terms interchangeably, gradient or slope. So here is a slope. Let's imagine we've got a man there, and this area of the ground is sloped. Here's another one, and what we have to decide first of all is which of these has a bigger slope. Now, there's no reason that the number we give this, like let's say it's 25, it could be any number. Should this one be bigger or smaller than 25? Could it be, for example, 50? Would that make any sense? Well, we tend to attach the meaning of the bigger number to the steeper slope. So that's the first thing. Steeper means bigger in terms of the number that we're going to give the slope. It could have been the other way round, but I think because we walk around mainly on flat ground, we say that is going to be 0, and a cliff edge is going to be maximum rather than the other way round. Next, we need a way to quantify a slope. So if we have a slope here, for example, we need to be able to attach a number to this so we can see if it's bigger or smaller than another slope, for example, that second one there. And one way of doing it is to measure for a given distance of horizontal travel what the vertical distance is, and we can refer to this as x and that as y. For example, as with a graph, when we've got the x-axis and the y-axis. And so what we can say here is the gradient is equal to the distance travelled in the y direction, which will be that distance, y distance, divided by x distance. And that is the distance you go in the x direction. Now this fits with our steeper being a bigger number, because if it's steeper, the y dimension, which is on the top of this fraction, will be bigger, and you'll end up with a bigger number. And if it's flat, for example, our x direction is whatever that is, so the gradient, just write grad, equals our y distance over our x distance. The y distance is 0. 0 divided by x is still 0, so that gives us a 0 gradient. If, on the other hand, it's a vertical line, then we have our x distance, which is 0, and our y distance, which is infinite, and this makes no sense at all. So this doesn't have a gradient, although you could say it's an infinite gradient. In terms of graphs, which is where you will use this a lot, we have to make decisions about gradients and their signs. Lines or slopes that go up and to the right, like these ones that I'm drawing here. These are all positive slopes by convention, and lines that go down to the right are negative slopes by convention. So these are all negative slopes. Because as you move to the right, you're going down. So those are all negative, 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 and negative. Now that's just something you have to remember. But think of this as positive, x is increasing and y is increasing. That's positive. Think of these ones as x is increasing but y is decreasing, and that's negative. When it comes to actually doing the calculations for a slope, the method used is to pick 2 points, and it doesn't matter really where they are. You can pick convenient points, but it will work with any points. And you imagine vertical lines to the x-axis, and then you've got x1 and x2, whatever these values of x are. This is the x-axis, of course. And you do the same for the y-axis. You draw horizontal lines in this case, and you get y1 and y2. For example, x1 could be 2 and x2 could be 5. Y1 could be 3 and y2 could be 7, for example. In this case, then we work out the difference in y, which would be, so we write gradient equals, and in this case, this distance here is 7 minus 3, which is 4. And here we've got 5 minus 2, which is 3. So that is 4 over 3. You can write that as a decimal if you want. And that gives 1.33, 2 decimal places. And you'll often hear the mention that the gradient is the rise over the run. So the y change is the rise, and the 3 on the bottom here in this example, or the x difference, is the run. So that's another way to help you remember. Gradient is rise over run. Rise being how far you go up, run being how far you go along. Now it's very easy in looking at these values of x and y to get them slightly the wrong way round. For example, if we had said, and this is incorrect, so we'll sort out a way to make sure we don't do this in just a second. If we'd said, oh look, I've got 2 here and 5, so I'll get these, the x is 2 minus 5. Now that's not what we said here. We said 5 minus 2, which gave us a plus 3 on the bottom there. But this time I'm getting them the wrong way around deliberately. And on the top we'll stick with 7 minus 3. And that gives 4 over minus 3, which gives a gradient of minus 1.33, 2 decimal places, and that is wrong. Okay, so we don't want to do that. It's definitely incorrect, incorrect, incorrect. Now, why has it gone wrong? Well, let's take a little aside here for a second and think about the way intervals work. Supposing you start off in the morning and you've got £10, and at the end of the day you end up you've bought something that costs £2, so you end up with £8. Now there's an interval here of £2. If we simply want to calculate the magnitude of the change by saying started with 10, ended up with 8, the difference is 2, then it's correct that it's a £2 difference, but what isn't reflected in this 2 here is the fact that it is a negative 2. In looking at the money you've got left, you started with 10, you ended with 8. The change has been -2 and not +2. So how do we get a change of -2? Well, it's very easy. You put the end condition first. So what we do is we say it's 8, and you subtract the start condition. And that's going to give you, in this case, -2. It does the sign for you when you do it as end minus start. If you don't do it that way round, the signs will be wrong. So always do the end minus the start. If you'd started off with £5 and you'd ended up with £7, then the end condition is 7, start condition is 5, 7 minus 5 is +2, and that is the change in this case. You've gone up £2. So if you do the end minus the start, it sorts the signs out for you. I'd recommend you do that with all intervals that you're calculating. And when we come back to here, we can see that the line has gone in terms of increasing x from x1 to x2. So this is our start, this is our end, and the corresponding y points are the same. So this one here is the start, and this one here is the end. And when you've got it written like this, it's very easy to make sure you never get this wrong. We just make sure that the x2, which is our end, is the one that's most to the right, always. x1, which is our start, is the point that's most to the left, always. So in this case, we're going to do end minus start for x. End was 5, start was 2, 5 minus 2, corresponding values of y, the end was 7, and the start was 3. And that's going to give us 4/3, both positive in this case, and that gave us the result we had over here at 1.33. So if you do that, it will always sort it out correctly for you, even in cases, and this does come up in practice, where, let's make it really, really tricky. Let's do this line here. Now, I did say if it goes down as you go to the right, it's a negative gradient. So we expect that to have a negative gradient. But to make it even more interesting, we'll have 1 point over here and we'll have 1 point over here. Okay, so that's going to be quite a difference in the way we've done it. We're going to end up with some minus signs here. So first thing to do is decide which one of these is x1 and which one is x2. Well, x1 is always the one on the left, so that's x1 there, and x2 is always the one on the right, so that's x2 there. With x2 goes y2 always, and with x1 goes y1 always. So let's give some numbers to this just to see how it might look. This is positive, let's make that 4, and this is negative, so let's make that -3. Y1 here is positive, so let's make that 2. And x1 here is negative, so let's make that -3. So the gradient then equals end, which is for y's, it's y2 minus y1. Remember, it's end minus start over x2 minus x1. And this is the only formula you need to remember for this. And it works all the time. So now we put the numbers in. Y2, where's y2? Oh, it's down here, so that's -3. And then we've got the minus sign, minus, and what's y1? Well, y1 is +2, okay? So that we'll just write that in as a 2. We divide that by x2, which in this case was +4. Just write 4. Then we've got the minus, and then we need our x1, and that's -3. So on the top we've got -3 minus 2, and that gives us -5. On the bottom we've got 4 minus -3. And when you subtract a negative number, it's the same as adding it, so that's 4 plus 3, which gives +7. So the gradient in this case is -5/7. You can turn that into a decimal on your calculator if you want. So we said this should be a negative gradient, and indeed it is. It's negative. If we just do this in our head, what is the approximate y change? Well, it's gone up 2 and down 3, so we're looking for 2 and a 3, which makes 5. Yep, so that works well. And then on the x direction, we've gone 3 in one direction, 4 in the other. That's a total of 7, so this works out fine. So this method will always sort out the signs for you and make sure you get them right. As long as you assign x1 first to the point which is most on the left, and x2 first or second to the point which is most on the right. Okay, don't get these the wrong way around. Don't go, oh, we'll have x1 there and x2 there. Okay, don't do that. Do it always, whatever points you have, x1 is there and x2 is to the right of it. Associate the y2 with x2, the y1 with x1, and then just remember this formula, and it'll always work out right for you. Doesn't matter where these points are, okay? There could be one up there and one down there. That would be your x2, that would be your x1. because this is most on the left, but you'll always get the right answer. Hope that helps, and that is all. Goodbye.